Just as we could add and subtract complex numbers, we can also multiply them. We're going to begin by looking at multiplying an imaginary number, 2i, times the complex number, 4 plus 8i. Now, while we could not add a real and an imaginary, just like we could not add a 2 and an x, 2 plus x is simply 2 plus x. So something like 2 plus I is simply 2 plus I. We can, however, multiply reals and imaginaries. So 2 times x is 2x, or 2 times 4x would be 8x. Those could be multiplied, but they could not be added. Imaginaries work the same way. The i's work very much like variables. So in multiplying this 2i times 4 plus 8i, we have to take this imaginary portion and multiply it by the entire complex number. Now, in order to do that, we have to remember about the distributive property. It applies here. So we multiply the 2i times 4, and we have to multiply the 2i times the 8i. 2i times 4 is 8i. 2i times 8i would be 16i squared. Now here's where we have to remember that I squared can be written in a simpler form. I squared is the equivalent of negative 1. This is something you have to remember because we will be using it frequently. So anytime we see I squared, we want to replace it with negative 1 because it's much simpler. So this is 8i plus 16 times negative 1. But we all know that 16 times negative 1 is simply negative 16. So if I have a choice, I'm going to write this simpler. 8i minus 16. So now we're down to a complex number. We simply need to rewrite this in the correct order. Remember, complex numbers, we want real first, then imaginary. So the real portion of this answer is negative 16. The imaginary portion is the positive 8i. So the answer to our multiplication would be negative 16 plus 8i. A second example would be negative 3i times 9 minus 4i. Again, we would use our distributive property to approach this. We have to multiply negative 3i times the 9 and the negative 3i times the negative 4i. Well, negative 3i times 9 would be negative 27i. Negative 3i times negative 4i would be a positive 12i squared. But again, we have to remember that that I squared is equivalent to negative 1. So we have negative 27i plus 12 times negative 1. And we all know that 12 times negative 1 is simply negative 12. So this is negative 27i minus 12. And writing this in our correct order so that we have real, then imaginary. Our real portion is negative 12, and our imaginary portion is negative 27i. Not only can we multiply an imaginary times a complex number, we can also multiply two complex numbers in much the same way that we multiplied two polynomials. We're going to start off by taking this real portion of our first complex number and multiplying it by our second complex number. So we will distribute 4 times 3 and 4 times negative 6i. Then we're going to take the second part of our initial complex number, this positive 2i, and we're going to distribute it to our second complex number as well. 2i times 3, and then a 2i times negative 6i. Once the distribution has been done, we can multiply. So 4 times 3 is 12. 4 times negative 6i is negative 24i. 2i times 3 is 6i. And 2i times negative 6i is negative 12i squared. Now we look for things that we can simplify. I notice two imaginaries here. These two imaginaries can be combined. I also notice that we have an I squared, and we remember that I squared is equivalent to negative 1. So this is 12. Negative 24i plus 6i would be negative 18i. Then negative 12 times negative 1. Well, we know this negative 12 times negative 1 is simply a positive 12. And once that is rewritten as positive 12, we should notice that there are another pair of like terms. We have a positive 12 and a positive 12 that are both real portion. So we can combine those. 12 plus 12 is 24, and the imaginary portion of our number is negative 18i. So the product of these two complex numbers is 24 minus 18i. We're going to take a look at one other multiplication. So far, when we have done this multiplication, scroll back to the beginning, we multiplied an imaginary times a complex, and we got a complex number. We multiplied an imaginary times a complex, again we got a complex number. We multiplied two complex numbers together, and we got a complex number. So it's looking as if multiplication by complex numbers is closed, meaning if you multiply something by a complex number, you're going to get another complex number. Well, let's see if that holds true. We're going to try one more example and see if the same thing happens. 2 minus 4i times 2 plus 4i. We'll start off the same way. We're going to distribute. We have to multiply the 2, the real portion of our first complex number, by the entire second complex number. So we'll multiply 2 times 2, and we'll multiply 2 times 4i. Then the imaginary portion has to be taken care of. So we're going to multiply the negative 4i times 2, and the negative 4i times 4i. And we do the multiplication now that we have distributed. 2 times 2 is 4. 2 times 4i is 8i. Negative 4i times 2 is negative 8i. And negative 4i times 4i would be negative 16i squared. Looking for like terms to combine, we have a positive 8i and a negative 8i. Well, positive 8i and negative 8i combine to give us 0 i's, which means there are none. They essentially undo each other, so we have no more i's left. And the I squared we know is equivalent to negative 1. So this is 4 minus 16 times negative 1. Well, 4 minus 16 times negative 1, negative 16 times negative 1 is a positive 16, so this leaves us with 20. Now, it looks like we only have a real part to this answer. However, technically, even though we didn't write it down, there really is a plus 0 I here. So even though it's not written, we do have an imaginary portion. It's just, its coefficient is 0. There are 0 of them. So we still have a complex answer, which means that no matter what we do here, when we multiply something by a complex number, we're still going to get a complex number, so they are closed under multiplication as well as addition and subtraction.